Hello Internet, welcome to my video about Microsoft Vss Volume Shadow Copy service. This is a functionality that supports most of application-aware backup applications on Windows, and it is also part of Windows backup and restore points. Let's get on with it. I will start by showing you where would you normally see this functionality in Windows. So let's say we are in Windows Server 2019. On the right click option in any of your volumes, you would see configure shadow copies and restore previous versions, two operations which allow you to restore old version of the disk or old version of the files. For example, if you go to configure shadow copies, you can even enable it and make it periodic. And if you enable this, you can put it on any of your disks, and then the shadow copy would basically allow you to roll back your system disk to previous state. So another most obvious scenario where you would see VSS in play is the fact that most of the time that when you do a Windows update or some kind of security feature installation or system upgrade, you get a system restore point. So system restore point is also another feature which is supported by VSS. So what is VSS? Let's take a look at this in brief. And after this video, the second video, I will show you how to use specific tools from Microsoft to troubleshoot if this doesn't work. But for now, let's just agree that we have a timeline. So the time goes by and you have a disk. So as you work with this disk, the applications write data and read data from the disk. It means that the actual data is changing. As you travel, let's say, along the timeline, so basically your disk gets changed more and more. At specific time, you can make a shadow copy, which will be a volume snapshot that will remember the exact state of your disk, or rather volume. And this would be, let's say, Tuesday at 10 AM. And if the disk keeps changing, at some point, let's say on Sunday at 9 PM, you realize that something is wrong or you must restore your system. And you can restore specific files, or you can overwrite the whole volume using the shadow copy, the shadow of your disk. So you can basically bring back the data you had. That's the way the concept works. You can also do it per folder. This is why you have two different options: previous versions and configure shadow copies. So previous versions can do it on folder level. So you can only shadow a single volume folder if you want. Let's say C Windows or My Documents. But the whole thing works on the same concept. So let's say you have a volume C, which you plan to make a shadow copy of. Right, on this volume you have some folders, let's say Windows, Documents, etc. So all of these folders and files, they are kind of available to the user to browse. But as you may know, there are some system and hidden folders which you cannot normally access. So for example, if I go to my Windows system on the C volume and go to the folder properties, I think it's somewhere in the view options, change folder options, I can make it display the hidden files and also the system files somewhere here. Hide extensions, uncheck, hide protected operating system files. Here we go. So now you'll where is it? Yeah, you'll see this folder, system volume information, which you cannot normally access. But this is a specific folder which stores a service data about your partition file system. So what actually happens when you make a shadow copy? There is a partition part, let's say something that is not used by files, allocated for shadow copy. And here you get shadow copy. The shadow copy itself takes 0 space at first. but you got to recognize that your disk is a block level device. So in reality, if you look above file system, like deeper, sorry, it's probably under, you look under file system. On the deeper level, closer to the actual physical storage, your data will be stored in data blocks. If you're unsure what I'm talking about, look up my video about data structure. So here we'll have, let's say, 64 kilobyte blocks. And the real files are stored in these blocks as content. Whenever you do the shadow copy, at first nothing is changed, but some area is pre-allocated for future shadow copy. This area which will be shadow copy in the future is called shadow storage. Shadow storage. Storage for shadows, basically, which will hold the shadow copies. And it's zero space used. As you keep working with the files which have been shadowed, if you do it with the disk, it will be the whole volume. Some blocks, let's say here we have block A, the block will be overwritten with block B, so different binary data. As it happens, the shadow copy stores block A. Then let's say you had block C somewhere here, which was overwritten by block D, and then block C goes in the shadow copy. And in order to restore your disk, the only thing you need to do is to basically roll back D with C and B with A. So if somebody is aware of concept of differential backup, the shadow copy is a differential backup of your volume. So as you change data on your disk, the old data that you replace is not replaced, is not erased, it goes into the shadow storage, which means that the shadow copy will grow. And theoretically, if you use 50% of your volume by real data, the other 50 can be used by shadow copy, simply because if you replace fully what's here, it will one-to-one go into the shadow copy. So it means that shadow copy needs to have space available on the disk. This is something that you can configure. You can limit how much space it can use. So for example, if you configure shadow copy in Windows, in the properties of the volume, and I enable it, let's say I do. Now I can go into the settings of the volume and select the limit. So right now by default it decided to use 4 GB of max. I can put it to the lower value, but then you should balance it with the actual shadow copy requirement. So you should kind of approximate how much space do you need for the change in data. By default, if you are working on Windows machine for a bit and use it for, let's say, system or system upgrade tasks, so you would delete shadow copy later and free the space, you probably wouldn't need more than 20% of the disk space. But if it is a highly transactional service and you want to use multiple shadow copies, which by the way depend on each other, so you could theoretically make another shadow copy, and then what to do, it would leave this data alone and start making a different portion of shadow copy. So you could basically tier it. It's like a chain of increments in the backup job. You would want to consider that at some point you can run out of space. Well, it wouldn't be critical for the system, because as soon as there is no more space for the shadow copy, it will be terminated, or the oldest one will be deleted if there are multiple ones. But you could lose your backup information if you do not provision enough space on the disk. So if your disk is full, you cannot really use this feature. However, you can imagine this is very handy, because you can easily preserve a part of your volume, like a folder which doesn't change much, and in the future, if you override this folder by mistake, you can always roll it back. So now the two parts of the video which are left to discuss before I make another video about actual troubleshooting and tools used. I want to explain how it works, what are the components, and finally how you can take a look at this by yourself. So how can you browse the shadow copy? So you could have trouble browsing shadow copy in different Windows versions. Why? Because initially when it was introduced in Windows XP, I believe, if we are talking about client versions, and definitely in Windows 2003, if we are talking about server versions, this feature was available up until now, which is Server 2019. However, in some iterations, I'm pretty sure in Windows 8, the functionality to browse the shadow copy was removed, and then it was reintroduced in Windows 10. So something here, I don't know, sit right with the Microsoft, and they decided to remove user ability to browse it, which was a bit strange to me, but that's the case. And you had to use third-party tools to navigate your shadow copies. So I want to show you the commands you can use, which will definitely work. So there is a tool called Vss Admin. In the older versions, you had IC or something like that with admin or whatever. So you had older version, but typically you would use Vss Admin to control the shadow copies in most of the modern systems. And there is disk shadow, but disk shadow is only available on server versions, so not on client versions. And if you're unsure what's the difference, the client version is something that you would usually purchase for a cheaper price and use it as a home or other kind of installations. So it's a client terminal system, and the server system would have access to extra functionalities such as Active Directory, Exchange server, other features, files features for scale-out file server, which would be deployed on server stations in data centers. And typically, server has more complicated UI, and server has more functionality for the actual server functionality, let's say. And you can decide by the name, because if you are talking about guest system or about client versions, they would have a shortened name like 8 or 10, and the server would have a full year in the name like 2008, 2012, 2016, 2019. So if this Windows has a full year in the name, it is a server version. Okay, but without further ado, let's decide what does actually happen now that we know that it stores the blocks. So theoretically, the only thing that shadow copy needs to do, it needs to start saving the old blocks into the new location as soon as you take it. So it starts taking a backup of the volume. But there is a transition phase, right? So let's say there is your disk, and there is a file being written here. This is MDF file, which is SQL database. So the file is already present, but it's being replaced by some new content. And as you save, in the middle of write, somewhere here, shadow copy starts getting created. So your blocks start saving in this hidden area. The good question is, at which point should it start saving blocks? What if the process writing is in the middle of transaction? Let's say we are saving critical information, like let's say bank account ID, and you only get half of it inside, and then your server crashes or something happens and you want to restore, and you restore the database file from the backup from the shadow copy. However, you have corrupt bank account ID, and maybe without this ID, your whole database is not functional. So how would we avoid this feature? This problem, sorry. In this case, the most logical thing to do would be to wait until this transaction is finished and then start making the shadow copy. So this is only one application. You could have also system application side, let's say, and file service side. You could have registry being saved, system DLL files, backup information about system itself, user data. So you have tons of different systems working at the same time, application systems. You could have also Exchange server running, Active Directory. You could have external connections for some application writing. And all of that would need to be prepared for the backup. So you would want to finish the most important transactions and start making the shadow copy. So by default, to avoid corrupted files, there is a specific Windows component called KTM, Kernel Transaction Manager. So naturally, the system would stop file transactions for a moment before the shadow copy starts being taken. But this Kernel Transaction Manager is only aware about the actual disk activity. It is not aware of any applications. So if you also have Exchange server working here with EDB file, right? If you have Active Directory working with NTDS .dit file, which is its database. So you will have multiple different applications which could be affected. And the single service cannot know about every application in the system, and there could be more applications added later. This is why there is this extra set of components called Vss Writer. And these writers will be different for each application. They can even be custom writers provided by the vendor of the application. So you'll have SQL writer. You'll have Exchange writer, etc. And the thing is that if you do not have the writer for a specific application, you can end up in a situation where the restored file of this application is corrupt. And if you do have writer, this writer guarantees that the application will be restorable. That's the whole idea of the writers. Now, typically writers come with the applications. So if you install SQL Server, you get SQL Writer. If you exchange Active Directory, you get NTDS Writer, etc. But some applications do not have the writers. For example, there are some third-party databases which do not have VSS writers, typically because they're designed to work with Linux systems which do not have VSS. However, Oracle does have it. So Oracle is a very advanced, robust database which can be used both on Linux and Windows, and even on Linux it has specific backup functionality. But that's not the point of the video. I'm just a big fanboy of the Oracle. These writers, what they do, they tell shadow copy when it can start. What's actually happening, the whole list of writers is executed, and once all of them are done, which means that every writer finished preparing an application for the backup, that's when shadow copy is executed. So the shadow copy is a specific step of tasks. Before we look at the tasks, let's see how can you actually check the writers. So the writers are installed in your system, and you can observe them by going to the PowerShell. Probably a good idea to start as administrator just in case. And here you have a command which I mentioned briefly, Vss Admin. And this command will tell you information and allows you to change settings about your shadow copy settings. So if you say list writers, in a moment it will give you the list of all the writers. Here you go. There is system writer for system files, performance counters for performance monitoring, task scheduler for a task scheduler. There should be registry somewhere here, registry writer. WMI is for Windows internal database instrumentation. So right now I don't have any extra features, but if I would install SQL Server, I would get an extra writer here. So what's happening is that there is a bunch of, let's say, conditions and specific steps that happen. I'll make a simplified list. If you want, I'll link a specific picture and article about functions that are executed if you want to make your own applications for VSS, but I'll make it simpler. So there is Vss Requester first, because VSS should come from somewhere. It could be a click in the UI in Windows, it could be a backup application, it could be a system activity, but there is always a requester. The requester is triggering something called Vss Provider. So the provider is the actual component which will tell shadow copy where to go and how. So whatever we use in Windows by default is called standard Microsoft software provider. So if you type Vss Admin list providers, I have to scroll down to show it here. This should show us the providers we have. And by default, there is this software shadow copy provider 1.0. And there's also file share provider, which is a bit interesting because it can work with remote shares, which means that theoretically you could make a shadow copy from Linux machine, which you present by SMB. But that's something that we don't need to touch today. So this provider will basically allocate specific area on a selected volume. For most of virtual backup applications, the shadow copy itself is configured on the same volume that you backup, because there is no deep transparency from the external layer. So theoretically, you could, for example, put shadow copy on a different volume. But if you are doing like virtual backups for virtual machines, most of the time the shadow copy would be on the same volume as you are backing up. So this provider would trigger the specific conditions. So as I mentioned, there is software type of provider, but there can also be a hardware type of provider. And the hardware provider comes from the vendor of storage device. A very good example is HP free power device, which comes from HP. And the difference is that the hardware provider can have its own rules, so it can override whatever was designed by Microsoft in terms of shadow copy. So normally you would have a volume here, right, this blue one, and you would have this green shadow copy inside of it, an area. What hardware provider does, it makes another volume, which will be a differential. So this will be a delta volume. And those who work with storage devices will recognize that this is called storage snapshot. So instead of doing the snapshot inside of the volume in Windows, the hardware provider can make a snapshot on the device as a different volume, which is a part of functionality of this device only. So the hardware device providers can bend the rules, can change them. That's the purpose of the providers, basically, in this case. So if you don't want to store your shadow copies inside of the same volume, which would probably require more space, you could use a special device which is advanced enough to have its own rules. Okay, so when provider says, okay, I'm ready to do whatever I want, there's the step prepare for backup. So on the step prepare for backup, each writer, so we have Vss Writer 1, 2, 3, 4, 5 up to 99. I don't know how many you have, it depends on the system, but all of them work through, and each of them has a timeout, and default timeout is 60 seconds. So each writer must finish working in 60 seconds. If there is exchange writer, for some reason they decided that it should be more sensitive, so that one has 20 seconds. But most of the other writers have said 60 seconds to finish work. So once all of these writers have finished working, the provider will get a good to go step. So after that, we actually perform the shadow copy. Here, shadow copy process starts. And if at some point you want to finalize the shadow copy, there is a command and backup, which basically says that everything is through. And this is a specific command which is used by applications like databases to perform so-called log truncation, where they clear up unneeded transaction logs. So basically it's a finalization of the backup. Now the shadow copy can be gone on this stage, but it can also persist, it can stay. So you can make non-persistent shadow copy, which will only exist for this time of backing up, which is used by backup solutions. Because what they do, they will grab this specific shadow copy, back it up in consistent state, and then delete it. Or it can stay as persistent for longer storage. So the Windows shadow copies you configure in these properties are persistent because they stay for a longer period of time to be used by users. So the only thing left today to show you, before I show you troubleshooting in the next video, is how you can make the shadow copy by yourself and observe and restore files from that. So you would have a better understanding of that. However, if you have any extra questions, I will be happy to answer them in the comment. So if we go to the server, we can use this utility disk shadow. And before I do that, let me make a file on my C volume. So here I'll make a file called do not delete.txt, and here I type like Zuko, which is my first cat's name. So I must be sure I will never forget about my first cat's name. This is a very important file. Now I'm starting this shadow, I add volume C, which is my volume, and I create the shadow copy. So only these two commands will make it. Which takes some time, so I'll probably have to cut it a bit, since it's a volume which has other applications. Now the shadow copy is done. Look, and I have an ID. And whoop-de-doo, by mistake, I delete my important file. Oh wait, it's my recycle bin, right? So I can still restore it. Right click, let's restore it. Oops, I think I clicked delete instead of restore. What do I do now? Well, I have my shadow copy. So I type expose shadow copy ID and Z as a letter. This doesn't work. Why? Because, as I mentioned, I just made a very basic shadow copy which is not persistent. So my file is lost for good. So if you are making shadow copies for actual restore purposes, make sure they are persistent and make sure they have a space. So let me fix that. I'll delete my shadow copy which is not persistent. Delete shadows. I could still roll back theoretically, but I will not do it because of one file. So I have removed my shadow copy, and it looks like I had another one before from my previous test. So now I have removed two. And you can also delete shadows all as I tapped here, but you can delete specific IDs. And let's repeat this test. So I'm going to my C volume. And I'm making another very important file because I'll still remember the name of my cat. Do not delete ever. And the cat name is, what was it, Zulu? I think it was Zulu. I'm pretty sure I remember it. Then in disk shadow, which I need to type properly, disk shadow, it's hard to type properly when the microphone is in front of the face. I need to have an arm for it. Disk shadow, add the volume C, and now I set context persistent. So now it will be a persistent shadow copy. It will be browsable. It will persist on the volume. And then I create it. Again, a few moments notice, it will be done. When you do this shadow copy, there is a chance that one of your critical application writers is failing. For example, SQL. So you could instruct your shadow copy creation to actually control the writers, but right now I'm doing the basic shadow copy which accepts errors. You could still see errors in the event viewer. So if you go to run and type event VWR, you'll see your event viewer, which can help you troubleshoot if something is wrong, most likely in application events. I don't know if I have any errors now. I'm just checking to show you where I would normally look. Right now, VSS seems to have worked. What about system events? NTFS, volume is healthy. Yeah, it even checks my shadow copy if it's healthy or not. And these are old errors. So now, right now I can see that my shadow copy is created properly without any errors. I have checked it in the event viewer. Normally I would pay more time to browse through the events to make sure there are no troubles if I'm curious about this, but right now it's not a problem. So now I'm deleting this with shift delete. So it doesn't even go into the recycle bin. So this file is gone. However, I still have this idea of the new shadow copy I made, and I know it is persistent. Here, in attributes, it has no auto release persistent, and as you can see, it's differential. So now we expose it as volume Z. So now I'll appear to have a new disk, which is actually one-to-one copy of my C drive, but whatever was deleted is here. Why? How it works? When you browse this Z volume, what's happening? Let me clear it up for a bit. You have your volume C already. What it actually is, it means that you have a hard disk. Like in my case, it's virtual because it's virtual machine, but let's say you have a hard disk and the partition here of specific blocks is allocated. And in Windows, this partition is mounted as letter C. What I did, I have created a shadow copy, which means that the part of the volume is now a differential backup, and I exposed this as Z or Z. And if the block is inside of this Z, it is read from this shadow copy because it's an older version of something I deleted, for example, this file. But if the block is in the original partition, it's going to be read through this So basically it will go and read the block from original partition where it's not present in Z. It's the same idea that I explained in the VMware Snapshot tutorial. So the differential volumes, differential snapshots, differential backups works that you read necessary data from the differential file, and if you don't have some blocks there, you go back until you reach the full backup or the full volume to read the rest of the data. So this is now what's happening. I'm browsing this Z, and it's not like I have two partitions on the disk. I have only one, but I have extra differential part of the volume, like a backup, which I can read from, and to Windows it looks like it's a different disk. And now the only thing left to do if I want to clean up, so I could leave it like this, but the shadow copy would start growing. I can actually check it by going into the Vss Admin. One thing you need to be aware of is that Vss Admin and Disk Shadow are two different tools. So they wouldn't share the same environment. So when one tool knows about shadow copy, another tool may not know about it. So the terminology, the functionality behind creation of shadow copy is the same, but the summary, let's say, or the knowledge or the metadata about the shadow copy will be different in different applications. So you could have two different applications making shadow copy at the same time without knowing about each other. And it will be provider's job, Vss provider's job, to properly allocate your shadow copy space. And if you use the same context, sometimes you could have an error that another shadow copy creation is in progress if you try to make a parallel shadow copy. So if I go to Vss Admin and I list shadows, I can see it. In this case, I can even probably delete it. Let's see if it can. And it tells me which provider it is. So because they're using this similar context, I think what would happen if you would try to make shadow copy using Vss Admin and Disk Shadow at the same time, they could clash. So if I do Vss Admin, delete shadows all, I think that's the command. It's probably /all. Look, so that's what I was talking about. So the snapshots were found, but they were outside of our allowed context. Try to remove them with backup application which created them. So because Disk Shadow is using a different metadata context, the Vss Admin is aware about the shadow copy, but it doesn't let you to delete it. So now I have to go back to Disk Shadow. I'll probably also want to unexpose this volume because it doesn't need to exist anymore. Now the volume is gone. It automatically closed my Explorer, but if I go to my PC, it's not here anymore. And now I can delete shadows all, which will get rid of the shadow copy. So as you can see, simply using PowerShell, you can already start making temporary backups of our system. Why I'm saying temporary? Because these are not the best types of backups. They are useful if you want to preserve your system state or volume state or file state, or restore files you removed by mistake or intentionally. However, this doesn't protect you from hardware corruption. If your hard disk would fail, you would be unable to restore from such backup properly because it would probably get corrupted too. So you would still want to have external backups. But this is a very useful tool. And also in the future, when I start talking about different backup applications, you will already be aware that this feature exists. And there are specific application writers which prepare applications for backup. Because other backup applications, such as Backup Exec, Vim, I think Commvault has one. I know there are a few others, but I mentioned the ones I worked with. They will trigger this Vss functionality to make good backups, which can be restored for specific application. Let's say SQL backups, which restore database in proper state. I will upload the next video shortly. The next video will give you an insight on how can you actually troubleshoot any errors which come from this kind of functionality. And otherwise, we'll keep looking into the context step by step. I don't want to overflow your perception with something that you haven't seen before. But if you do know about this and you have specific questions, I welcome your comments. Also, I rarely say it, but if you would like to, please like the video and subscribe if you are interested in more content like this. That's going to help me share my knowledge with more people. And otherwise, I'm looking forward to see you in the next video. And I wish you a great day. Bye bye.